Alright, so today we'll be labeling our periodic table. We'll start with the first group over here. Alright, and then the next one we're going to do is the alkaline earth metals. They'll be in group 2. Alright, so group 2 is going to be the alkaline earth metals. I've done mine in green. Next ones we're going to do is the transitions. Alright. The next ones we're going to do is going to be the stair steps. So these ones will be right. So now we have our metalloids. So we have this piece. This would be metalloids or semi-metals. This one would be Alright, next one will be your halogens. Alright, next one is the noble gases. And then we'll have other metals. All right, and then hydrogen is special because although he's on the left side with metals, he exhibits properties of nonmetals. So hydrogen is another nonmetal. So he's the only one on the left side is a nonmetal. He's with other nonmetals like oxygen, nitrogen, hydrogen. And then lithium down, these are your alkali metals here. These are the alkaline earth metals. Then we have two groups down here. These are the lanthanides. And then together, these are inner transition. All right, so these are supposed to be the inner transition metals. And that'll be all. And then there's a lot of properties that we can get from our periodic table. Mine is red. So I can find the number of valence electrons. Valence electrons are just electrons that are in the outermost shell. So I know that this one will have 1, 2, 3, 4, 5, 6, 7, 8. Except for helium. Helium is special because although he's a noble gas and he has a full outer shell, that S shell that he has can only hold 2. So he has 2, although he's in the halogens. Most everyone else has 8 in their outer shell. And then the next piece of information I can get from our periodic table is the number, it's ionic charge. So whether it wants to lose electrons or gain electrons. So my metals, they all want to lose electrons. So on this side, we're going to have positive charges. My nonmetals, they want to gain electrons. So these are negative charges. Then the noble gases don't like to lose or gain electrons, so these have 0 charge. They don't form an ion. But my nonmetals like to gain electrons. So we look at something like fluorine. Fluorine has 9, 2 in the first shell, and 7 in the outer shell, 7 valence electrons. So he just needs 1 to gain that full outer shell to have 8 in the outer shell. And same thing for oxygen, 2 in the first shell, 6 in its valence electrons, and he just needs 2 to be full in its outer shell. subshells. All right, so this will tell me the energy levels or the number of orbitals each one has. So in row 1, we have one energy level, that's S. And then here, row 2, we have 2 energy levels, 2 subshells. Row 3, 4, 5, 6. And then now we get All right, the first thing we'll talk about is atomic radius. So atomic radius, as we go from bottom to the top, is going to decrease. So we put a D next to that because this one's going to decrease. So atomic radius decrease simply because I have less shells. So francium has 7 shells. He's real big. And then as we go for hydrogen only has 1 shell, so he's real small. And then as we go from left to right, they decrease because we have more protons in the nucleus. So lithium only has 3 protons, so he can only pull those electrons in so hard. Fluorine has 9 protons. He can really pull those in, so it makes it smaller because he's so strong. So for electronegativity, as we go from bottom to top, it's going to increase. Left to right, it's going to increase. So for these ones, as we look at something like calcium, electronegativity is my ability to attract protons. And so for calcium, calcium has 20 protons. As we go to this one, it has 20 protons, but it has 4 subshells. With 3 subshells, these are smaller. So the electronegativity is higher, or its ability to attract electrons, simply because the electrons are closer to the nucleus. No. Just go to the bathroom. Okay. And then for electronegativity, it's going to increase because we have less subshells. So these electrons are closer to the nucleus, closer to the protons. As we go from left to right, electronegativity increases because we have a larger number of protons within it. So potassium has 19 protons, bromine has 35 protons. So he has a higher electronegativity, or a higher ability to attract his electrons because he has more protons in his nucleus. All right, and the last one is ionization energy. And so ionization energy is the amount of energy that's required to ionize an element. So as we go from bottom to top, ionization energy increases because these are going to be closer. So something like barium, its farthest electrons or valence electrons are really, really far away from the nucleus where the protons are that are going to be attracting you. Something like magnesium, it only has 3 subshells. So those electrons, the valence electrons, are very, 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 very close. They're not very far away. As we go from left to right, so we look at potassium. Potassium has 19 protons. Bromium has 35 protons. So these are going to be a lot harder to take away. It's going to be harder to ionize this one because it has so many protons. This one will be easier to ionize because it has less protons. All right, and that's it for your periodic table of elements.